Hello everyone. This video is the refresher topic about economic concepts as well. So the fundamentals of this topic is about the relationship between total, average, and marginal, as well as to perform the conversion between these three. So I have selected some problem sets that are involving the concepts of total, average, and marginal with the use of Excel and GeoGebra calculations. So I'll take benefit as an example for illustration. So we have total benefit, average benefit, and marginal benefit here. So total benefit would be the value that you can obtain from pursuing an activity, whereas average benefit is a value that you can obtain per unit of the activity. So average benefit can be calculated as total benefit divided by quantity. So you can think in that way. How can you calculate your GPA, your grade point average? It would be your total grade point divided by the number of courses that you have taken, right? So this is how you can calculate your GPA, the grade point average. When we are talking about average, we're dividing something about total by quantities or the number of courses. Finally, we have marginal benefit, which is the additional benefit that you can gain from pursuing an additional unit of the activity. So we have divided into two further cases, the discrete case and continuous case. So for the discrete case, marginal benefit of the nth unit would be the total benefit of pursuing n units minus total benefit of pursuing n minus 1 units. For the continuous case, it will be as follows. You're going to find the change in total benefit after increasing the quantity very little. So this is why the marginal benefit equals to the derivative of total benefit, dTB dQ. Okay, so this is the benefit side. We have something similar on the cost side. So total cost will be the cost of producing the total amount of output. And by the way, total cost can be decomposed into two parts, fixed cost and total variable cost. How about average cost? It will be the production cost per unit of output produced. So it can be calculated. Again, the total divided by the quantity. And finally, the marginal cost. It would be the additional cost required to produce one additional unit of output. We divide into two further cases. The discrete case, marginal cost of the nth unit equals to total cost of producing n units minus total cost of producing n minus 1 units. And for the continuous case of marginal cost, we are trying to find out the change in total cost after increasing your output by a very small amount. So we have marginal cost equals to dTC dQ for a continuous case. Okay, so to sum up these examples, we have the following relationship between total, average, and marginal. Somehow, total is actually the thing connecting average and marginal, so I put it in the middle. So if you have total and you like to calculate average, divide it by quantity. And in other words, if you have average and you would like to derive the total, then you just multiply average by the quantity. So how about the right-hand side about the relationship between total and marginal? So by definition, marginal is the difference in total, right? So if you're talking about the marginal benefit of the third unit of the activity, then it would be the total benefit of 3 units minus total benefit of 2 units, right? So marginal is the difference between total. It's the other way around. So if you have marginal and you want to find out total, then you can recognize that total is the sum of marginal. And here, just a caveat for you is that the sum of marginal cost is not total cost, but total variable cost, because the fixed cost part is actually cancel out each other when calculating the marginal cost. So this is the highlight for you. And the final thing to review is the marginal revenue under simple monopoly pricing, or we also say that single price monopoly. So nothing special in a discrete case. And marginal revenue of the nth unit equals to total revenue of n units minus total revenue of n minus 1 units. Under a continuous case, it will be as follows. The marginal revenue curve will have twice the slope of the demand curve. So if the demand curve is in the form P equals to A minus BQ, then the marginal revenue is this one, A minus 2BQ. The coefficient in front of Q is multiplied by 2 to obtain the marginal revenue curve in the continuous case, where quantities are perfectly divisible. All right, so that's all for the recall part, and we'll move on to the application problem sets. The first one is about a discrete case of cost and benefit analysis. So Bill is going to find out the number of investment projects to be taken, and we have the total benefit of investment to be this expression, 1,333 times square root of n. So what would be the number of investment projects that Bill would take in the coming year if the number of investment projects can only be integers? As a rational individual, you're going to find a point where the total economic surplus is maximized. Okay? So we are trying to do the calculation in Excel to find the value of n such that total economic surplus of investment is maximized. So let me shift my screen to Excel to calculate everything with you. So we have an empty spreadsheet here. Because we need to find out the total economic surplus, which can be calculated as total benefit minus total cost. So this is why I have the column total benefit and total cost here. So how can I do that? For the first column, number of n, nothing special. We just type 1, 2, 3, and so on, right? So to quickly do that, you can first type 1 for the first cell, and then second cell onwards, it could be the previous cell plus 1. Since this logic applies to the remaining units, then you can just pull down, or to use the shortcut key, Control plus D, D for down, and to obtain the column here. For total benefit, it can be calculated as 1,333 multiplied by square root n. Okay, so let's do that. Type equal 1333 times square root of n. Okay, the square root of n can be calculated using the function here, sqrt, and then reference to n equals to 1. Then we have the total benefit when n equals to 1. Since this logic applies to remaining value of n, we can just pull down, or to use the shortcut key, Control plus D, D for down, to obtain the whole total benefit column here. How about total cost? It is decomposed into two parts, the lump sum corporate tax of $500 and also cost per investment project, $230. This means that when n is equal to 1, the total cost will be 500 of lump sum tax plus the cost per investment project, $230. So we multiply that by n, and we have the total cost. And again, this logic applies to the remaining cells, then we can obtain the whole total cost column. How about total economic surplus? It would be total benefit minus total cost. And then we can pull down to obtain the whole total economic surplus here. And we can now conduct our analysis to find the point where total economic surplus is maximized. As you can see, when n is equals to 8, the total economic surplus is maximized. So this is why Bill should take 8 investment projects in the coming year using this approach. So this is method 1. We have method 2 is to use marginal. So instead of finding the point where total economic surplus is maximized, we have another equivalent rule as a rational individual, which is to continue investing as far as the marginal benefit of investment is greater than or equal to the marginal cost. So this is why we would like to calculate the marginal benefit and marginal cost. So for the marginal cost side, it is simple. $230, the cost per investment project. How about the marginal benefit? We need to calculate that from the total benefit function. Be aware, we are dealing with a discrete case. Don't try to find out the marginal benefit by differentiating this thing. Okay, it would be wrong if you say that the marginal benefit is this expression. All right, so let's continue. The correct way to calculate marginal benefit is this one. Total benefit of the nth unit minus total benefit of n minus 1 units. So this is why we like to have the total benefit column here. Okay, let me copy and paste the first 2 columns here about the column n and the column for total benefit. So how can we obtain the marginal benefit column? For the first unit, it is simply 1,333 minus the total benefit of 0 units, which is simply 0. And for the second unit onwards, it will be the current unit minus the previous unit. The marginal benefit of the second investment project equals to total benefit of 2 investment projects minus total benefit of 1 investment project. And since this logic applies to other value of n, then we can obtain the whole column. Marginal cost, it will be 230 for all value of n. It's constant marginal cost. And as you can see, until the 8th investment project, the marginal benefit is still greater than the marginal cost, but not for the 9th investment project. So this is why, by the marginal approach, we can also find out that Bill would take 8 investment projects in the coming year. So let's conclude the remarks here. So sometimes you may mix up with the total approach and margin approach and try to find out the point where total economic surplus is greater than or equal to 0. So this is wrong, because as a rational individual, you're going to find the end where total economic surplus is maximized, but not the total economic surplus is still positive. Okay? Either you are finding the point where total economic surplus is maximized, or to use the marginal approach to find the point where marginal benefit is greater than or equals to marginal cost. The second remark, be aware whether you are dealing with a discrete case or a continuous case. If you're dealing with a discrete case, you calculate the marginal benefit using the difference in total. Right? So this is exactly the approach that I've just demonstrated in this question. Instead of differentiating the total benefit function, and if I'm trying to differentiate the total benefit function to obtain the marginal benefit, the assumption is that the value of n, the number of investment project, is perfectly divisible. The remarks here concludes this problem, and we'll move on to the next question about the resource allocation. So we have 3 warehouses, and we would like to find out the number of trucks to be allocated to these 3 regions. Suppose there are 8 delivery trucks available. What is the number of trucks allocated into these 3 warehouses to maximize the output delivered? So we are going to find out the marginal benefit that can be generated from allocating 1 additional truck to the warehouse. Okay. So by the way, for the table on top here is the information directly given the question. Okay, so how can we calculate the marginal output by allocating 1 additional truck to that warehouse? So when the first truck is allocated to warehouse A, so when there is 0 trucks, then no output can be delivered to warehouse A. And if there's one truck in warehouse A, then 180 units can be delivered. So this is why the marginal output is simply 180 minus 0. How about when the second truck is allocated to warehouse A? Then the additional units that can be delivered equals to 354 minus 180 as the additional output that can be delivered, the marginal units. And this logic applies to the remaining cells in this column. You can just pull down to obtain the whole marginal unit column for warehouse A. And on the same token, this logic applies to warehouse B and C, and we can just pull to the right to obtain the whole marginal unit table. And we can conduct our analysis. So we have 8 delivery trucks to be allocated. So to maximize the output delivered per hour, what would be the number of trucks allocated to these warehouses? If you allocate the first truck to warehouse A, then 180 additional output can be delivered. If you allocate the first truck to warehouse B, then 293 additional units can be delivered. Whereas if you allocate to warehouse C, 255 additional units can be delivered. Obviously, 293 is the greatest number. This is why the first truck should be allocated to warehouse B. How about for the second truck out of these 8 trucks? If you allocate the second truck to warehouse A, it is simply the first truck in warehouse A. So we're looking for the number 180. If you allocate this second truck out of the 8 trucks to warehouse B, it becomes the second truck in warehouse B. The additional units that can be delivered is 248. Finally, if you allocate this truck to warehouse C, then it is simply the first truck in warehouse C. So we are looking for the number 255. And comparing these 3 numbers, 255 is the greatest number among the 3. Then the second truck should be allocated to warehouse C. And if you continue this logic until the 8th truck, you should be able to find out the optimal allocation, which is to allocate 1 truck to warehouse A, 4 to warehouse B, and 3 to warehouse C. And these are the numbers I have bolded in red. All right, so let's continue with question 6. Suppose the business owner wants to deliver at least 1,623 units of output per hour. How many delivery trucks has to be used? Let's see. If we have only 1 truck, then this truck should be allocated to warehouse B, and the total output will be 293. Obviously, it has not yet attained the target 1,623 units of output in total, right? So this means that we need to continue using more trucks. If we have 2 trucks, then the second truck should be allocated to warehouse C. And then the total output will become 548. Again, not yet attained the target. So how about if we have 3 trucks, then the third truck should be allocated to warehouse B. You can actually observe this number, right? The sum of the cell that I have quoted here, okay? When there are 3 trucks not yet attained the target, how about 4 trucks? 5 trucks? 6 trucks? 7 trucks? As you can see, when there are 7 trucks, the total number of output is exactly 1,623, which is the desired target. So to conclude, at least 7 trucks are needed to deliver this number of output per hour. Okay, so that's all for this problem about resource allocation. And we'll move on to the next one about treasury of the commons. So for question 46, if the residents make their decision individually, what would be the number of steers to be sent to the grassland? So let's see. We can actually calculate the information in Excel, right? So if there are 100 residents, Then we have n from 1 to 100. Right? So we just type the first cell as 1 and the second cell onwards, previous cell plus 1. And then just pull down this until we have n equals to 100. How about the second column about average profit? The question says that each of them can generate a profit of 27.5 minus 2n if there's n steers invested. So this is why 27.5 minus 2n is actually the average profit, the profit that each resident can obtain. So it is 27.5 minus 2 times n. And we can just pull down to obtain the whole average profit column. If residents make decisions individually, as far as the average profit that each resident can gain is greater than or equal to 0, then the resident would continue investing in steers. So this is why when residents make decisions individually, 13 steers will be sent to the grassland, and this is the market equilibrium outcome. All right, so this method of calculating in Excel is the same as what I'm trying to solve it in an inequality form. For question 47, to find out the socially optimal number of steers to send to the grassland, when we are talking about social optimality, we would need to find out the marginal profit, because the social optimal point is to find out the point where total profit is maximized, where the equivalence condition is marginal profit is greater than or equal to 0. So how can we calculate marginal profit if we only have average profit? Recall the relationship. Average and margin are two ends, right? So we need to calculate total profit, the middle one, to connect the two. So let's calculate the total profit column first. To find total from average, it is average profit multiplied by n. And we can obtain the whole total profit column. Whereas for marginal profit, for the first unit is simply 25.5. Second unit onwards is the current unit minus the previous unit. Marginal profit of the second steer equals to total profit of 2 steers minus total profit of having only 1 steer. And we can just pull down to obtain the whole marginal profit column. The decision rule is that as far as the marginal profit is greater than or equal to 0, then it would be socially optimal to invest in steers. So as you can see here, it is socially optimal to invest in 7 steers. Okay, so that's all for this part about the treasury of the comments. Next question now, it will be about the discrete case of simple monopoly pricing, where the quantity can only take integer values. So we have the demand function, the marginal cost of serving an additional customer. Given this information, what will be the price charged by the zoo, the monopolist? So although the question gives you a demand function in this form, it is wrong for you to say that the marginal revenue equals to 1,750 minus 110 Q. Okay, it is wrong by multiplying the coefficients in front of Q by 2, because by doing so, we assume it is a continuous case where quantity is perfectly divisible. However, as mentioned here, Q can only take integer values. So this is why we need to use the discrete case of marginal revenue. Marginal revenue of the Q unit equals to total revenue of serving Q customers minus total revenue of serving Q minus 1 customers. Again, we can do the calculation in Excel. So let me shift back to Excel to do the calculation with you. So first of all, the first column is the quantity, the same technique in obtaining the column here. Okay, so how about the price column? It can be calculated using the demand function, 1,750 minus 50 5 times the quantity. For the total revenue column now, it will be price times quantity. And with these, we are ready to calculate the marginal revenue. Okay, for the first unit, it is 1695. Second unit onwards, current unit minus the previous unit, because marginal revenue of the second unit equals to total revenue of serving 2 customers minus the total revenue of serving only 1 customer. And we have the marginal revenue column. Finally, for the marginal cost, constant at 140 for all units. The profit maximization condition is as follows. As far as the marginal revenue is greater than or equal to the marginal cost, then it will be profit maximizing to serve an additional customer. As you can see, until the 15 unit, the marginal revenue is greater than the marginal cost, but not for 30 units. So this is why the zoo should serve 15 customers. And the corresponding price, according to the demand curve, is 925. And this is how we can solve the problem. And to conclude this, I have actually put down the 4 steps here. And these 4 steps are actually quite universal in dealing with simple monopoly pricing. Right? So just now, the first step, we are deriving the demand schedule. Right here, the first 2 columns, expressing the relationship between price and quantity demanded. Step 2 is to obtain the marginal revenue column here. Step 3 is to determine the profit maximizing output using the MR is greater than or equal to MC, profit maximizing condition. Step 4 is to set the monopoly price according to the demand curve at this profit maximizing quantity of 15 units. So we have the profit maximizing price 925. So this is how we can use the 4 universal steps to deal with simple monopoly pricing. All right, so finally, we have another problem of simple monopoly pricing right here. This time, the question did not specify that the quantity has to take integer values. This means that it's perfectly divisible. Okay. So we are going to find the profit maximizing price and quantity produced by the railway monopolist. So even when we are dealing with a continuous case of simple monopoly pricing, we can follow the 4 universal steps that I have outlined just now to you. Okay. Step 1 is to derive demand curve. Since it's already directly given in the question here, and we have nothing to worry about step 1, and we can directly move on to step 2, obtain the marginal revenue curve. This time, because we are dealing with the continuous case, so we just multiply the coefficients in front of Q in the demand curve by 2. So this is how we can obtain the marginal revenue expression. All right, so let me shift my screen to GeoGebra this time, because we can plot a graph to solve this problem. Let me type the demand and marginal revenue here first. All right. Step 3 is to determine the profit maximizing output using the profit maximization condition, MR equals to MC. In this question, we know that the marginal cost is fixed at $4. So we just draw a line at $4, and this will be the marginal cost of production. So the intersection between the blue curve and the red curve, intersection between MR and MC, would give you the profit maximizing output. Point A will be giving us the profit maximizing output, 233.33. And finally, step 4 is to charge a monopoly price according to the demand curve at this profit maximizing output. So at the quantity of 233.33, the corresponding price according to the demand curve is this one. Right? Point B will be giving us such an information, where the profit maximizing price is $74. So this is how we can use the 4 universal steps to deal with problem involving simple monthly pricing. As you can see, we need to use different tools to solve the discrete case and continuous case respectively. So don't mix up the techniques. Yeah, so this is also a screenshot of this problem to find out the profit maximizing quantity and price. That's it, and it will be all that I would like to cover for this topic about the concepts of total, average, and marginal. Hope this will also consolidate your understanding in the economic concepts. Thank you.